Hi everybody, let us start our discussion with dynamic programming. Dynamic programming is a technique to break complicated problems into simple subproblems. One of the approaches is recursion. Recursion is a technique where a function calls itself to perform a certain task. In order to solve any dynamic programming problem using recursion, we need to know the recursive case and the base condition. In Fibonacci series, we know the value at any position n is the sum of the previous two values, that is value at n-1 and n-2. Thus we got our recursive case here. For example, if we want to get the value of fib of 5, then it will be equal to fib of 4 plus fib of 3. Similarly, fib of 4 equals to fib of 3 plus fib of 2, and so on. We need to stop at some point to get the values, which is our base condition. In this case, fib of 0 equals 0 and fib of 1 equals 1 are the base conditions. Let us visualize the recursion. Say we want to evaluate the fib of 5. As per our recursive case, it will be equals to fib of 4 plus fib of 3. Let us evaluate the left child, that is fib of 4, which is equals to fib of 3 plus fib of 2. Once again, let us evaluate the left child, that is fib of 3, which is equals to fib of 2 plus fib of 1. One more time, let's evaluate the left child, that is fib of 2, which is equals to fib of 1 plus fib of 0. Now we know the values of fib of 1 and fib of 0 as they are our base condition. Thus fib of 1 equals 1 and fib of 0 equals 0. Let us add both of them to get the value of fib of 2, which is equals to 1. Now move to the right child of fib of 3, that is fib of 1. We know it is the base condition as well, so fib of 1 equals 1. Let us add both of them. We will get the fib of 3, which is equals to 2. Now we already know the value of the left child. Let us switch to the right child, that is fib of 2. Again fib of 2 equals to fib of 1 plus fib of 0. Again we know that these are our base conditions, so we know the values of both of them. Let us add both the values, that is 1 plus 0 equals 1. Now we know both the child's value, that is fib of 3 equals 2 and fib of 2 equals 1. Let us add both of them to get the value of fib of 4. Now let us switch to our right child, that is fib of 3. So fib of 3 equals fib of 2 plus fib of 1. And again let us move to the left child, that is fib of 2, which is equals to fib of 1 plus fib of 0. And as we already know, these are base conditions. So let us add both of them to get the fib of 2. And let us switch to the right child, fib of 1. We already know the value of it. It is 1. Let us add both of them to get the fib of 3. And finally, let us add the left child and the right child to get the value of the fib of 5, which is 5. Once again, let us visualize how recursion works on memory level. As we know, the stack memory area stores local variables and the argument passed through a function. After function completes its execution, data belonging to it flushes out immediately. Keeping these things in mind, let us jump to visualization part. Suppose again we want to evaluate fib of 5. As we know, stack follows last in first out principle, so we only have fib of 5 in the stack. So fib of 5 we're going to evaluate and results to fib of 4 and fib of 3. Again, as per the stacks principle, fib of 4 we're going to evaluate and it will result into fib of 3 and fib of 2. And similarly again, fib of 3 we're going to evaluate and it will result to fib of 2 and fib of 1. And once again, fib of 2 we're going to evaluate as fib of 1 and fib of 0. At this particular stage, we hit our base condition, that is fib of 1 equals 1, fib of 0 equals 0. Let us add both of them it will result to 1 and it will be returned from that particular function to the previous function. Now it will be stored as a local variable. Again we will follow the stack principle, and now we will evaluate the fib of 1 again, which is equals 1. Again let us add both of them and we will have 2. Again, as per the stacks principle, fib of 2 we're going to evaluate as fib of 0 and fib of 1. Again, fib of 0 and fib of 1 are the base conditions. Fib of 0 will be 0 and fib of 1 equals 1. Let us add both of them and add to the previous value, that is 2. It will be 3, and lastly we will evaluate fib of 3, which is fib of 2 and fib of 1, and fib of 2 will evaluate as fib of 1 and fib of 0, and these are base condition which results to fib of 1 equals 1 and fib of 0 equals 0, and finally fib of 1 equals 1, and finally we have 3 plus 2 as the result which will be returned from the function. Let us try to implement the Fibonacci series using recursion. Let us first define the function, say fib3, which we're going to accept one parameter. As we already know, to implement the recursion we need to satisfy two conditions. So one is the base case and another is the recursive case. So let's jump into the base conditions first. So if number is less than 2, then we will going to return that number, since we know fib of 1 is 1 and fib of 0 is 0. If number is greater than 2, then we will go with the definition of the Fibonacci series, that is our recursive case as well. Let us compile the program and now call this particular program, say fib of 3, and we want to get the value at index 7, which is 13. Now let us try with a larger number, say 26, and try to evaluate that. Okay, let us go a little bit up, say 50, and we can see like program is taking a long time to get the result. Let us try to address this particular problem. Until this point we already know how recursive calls look like. Let us try to point out the problem which was restricting us to evaluate the higher numbers. From the tree structure, we can see that we are evaluating fib of 2 multiple times. Similarly, fib of 3 is also getting evaluated multiple times with our current approach. This is the case with a small number, that is 5. We can imagine how much duplication we are having for the higher numbers, say 50. Let us try to address the issue which we are getting right now with the recursion. So we will be addressing this issue using memoization. Memoization is a technique which will store the computation results and retrieve the same information when needed again instead of evaluating. Let us try to visualize this first. Now again we are evaluating fib of 5. So fib of 5, using recursion we're going to call fib of 4 and fib of 3, and fib of 4 we're again going to call fib of 3 and fib of 2, and again fib of 3 we're going to call fib of 2 and fib of 1, and finally fib of 2 we're going to call fib of 1 and fib of 0. At this point we hit the base condition, that is fib of 1 equals 1, fib of 0 equals 0. Let us try to add both of them and evaluate fib of 2. Now instead of moving to right child, memoization technique will store this result, that is fib of 2 as 1, and we will retrieve it afterwards when needed. Now let us jump to the right child, that is fib of 1. We know the value of fib of 1, which is 1. Let us add both of them to evaluate fib of 3. Now instead of jumping to right child again, we will first store the fib of 3. Now let's jump to the fib of 2, that is the right child of 4. Now instead of evaluating it, we will first look it into the table if we have the value for the same. And guess what? We have the value for that. Let us get the value of it. That is 1. Now add both the values to evaluate the fib of 4. Now instead of jumping again to the right child, let us store the fib of 4 first to the table. And now jump to the right child, fib of 3. Now instead of evaluating this value, let us first look it into the table. And guess what? We have the value for that. That is 2. Now let us add both of them and get the value for the 5 and return it. Let us try to implement the Fibonacci series using recursion with the help of memoization. Let us first define the memo. Memo is nothing but a dictionary in case of Python. And I'm just going to define the piece condition over here. So whenever my function will ask for the Fibonacci series at position 0, then it will return 0. And if my function will ask Fibonacci series for 1, it will return 1. Now let's define the function fib of 4, which we're going to accept the number. Now if number is not in memo, in that case we will going to evaluate the number. Say number at position n would be fib of would be the sum of the two previous numbers, and remember, like, we were not just going to return the number, however we were going to store that number in the memo and finally return the number. Okay, I have already compiled this program. Let us try to call the fib of 4 for the position at 7th index. It is returning 13. Let us try to call the function with a higher number, say 50. Now it is returning the value instantaneously.